The numerical relationships between the chemical amounts in a balanced equation are called reaction stoichiometry. Basically, it's been said in your book, if we have to make pizza, we need 1 crust, 5 ounces of tomato sauce, and 2 cups of cheese. So if we have 6 crusts, 14 cups of cheese, and 20 ounces of tomato sauce, we would calculate it like this. 6 crusts and 1 pizza needs 1 crust. Therefore, you can only make 6 pizzas. The crust is on the bottom and the pizza is on top, so the crust can cancel out and you're remaining with pizza. 14 cups of cheese. 1 pizza needs 2 cups of cheese. Therefore, you can only make 7 pizzas. 20 ounces of tomato sauce. 1 pizza needs 5 ounces of tomato sauce. Therefore, you can only make 4 pizzas. You make sure pizza's on the top and ounces of tomato sauce is on the bottom, so tomato sauce can cancel out and you're remaining with pizza. We have enough tomato sauce to make only 4 pizzas, so tomato sauce is our limiting reactant, which gives us the smallest number of pizzas. The 4 pizzas would be our theoretical yield, which is the amount of product it can be made in a chemical reaction based on the amount of the limiting reactant. You should always remember that the unit you get at the end is always the numerator, so it's helpful before starting the calculation to put it at the end to constantly remind you and show you should cross out the units to get that as your end result. You can use this in reactions to find out how much product we would get, like this example. 2NO plus 5H2 equals 2NH3 plus 2H2O. With 86.3 grams nitrogen monoxide and 25.6 grams hydrogen, and we want to find the theoretical yield of ammonia in grams. We start with calculating how much ammonia we would get from nitrogen monoxide. So we have the weight of nitrogen monoxide, and at the end of the solution, we want to get moles of ammonia. We start by changing the grams of nitrogen monoxide to moles of nitrogen monoxide, and we can get that from the molar mass. Molar mass of nitrogen monoxide is 30.01 grams per mole, and since we want to get rid of the grams and get it in moles, we put 1 mole of nitrogen monoxide over 30.01 grams of nitrogen monoxide. So the grams would cancel out, and then we're left with the amount of nitrogen monoxide in moles. But we want to get NH3, the product. So according to the balanced equation, we have 2 moles of nitrogen monoxide and 2 moles of ammonia. Therefore, put the moles of NH3 on top and NO on the bottom to cross out the moles of NO and get our product NH3 in moles. The result of this is 2.88 moles of NH3. We do the same thing for H2 to find out which substance is our limiting reactant. We get 5.069 moles NH3 as the result. Based on our calculations, we get nitrogen monoxide to be our limiting reactant because it makes the least amount of product. Now we need to find the weight of product NH3. We use the amount of NH3 we got from the limiting reactant to get the theoretical yield, and we use ammonia's molar mass to convert the amount from moles to grams. The molar mass of NH3 is 17.03 grams per mole. After calculating, you get 49 grams of NH3. You should change the mass of the compound using the molar mass to moles or vice versa. You should then use molar ratio using the balanced equation to solve stoichiometry problems.